So is fever dangerous? When I was a child, I was told it is dangerous. And how do you think about this?
Yeah, many parents think fever is dangerous, and some parents already think that like 38.5 degrees or 39 degrees is highly dangerous for the child. According to all we know, the fever itself, the temperature itself, is not the danger. Of course, something behind the fever can be dangerous and may need to be treated, but the fever itself is not dangerous, is not a danger if the patient is a normal patient. If you have a brain injury, or if your brain has had too little oxygen, or if you have a there you actually might want to cool the brain even to help it overcome the injury. So there fever is detrimental. Or if you have a cardiovascular problem where you cannot deal with the increased energy that fever costs, there again, fever could be a disadvantage. You can see that, for example, also in some animals, if they have a bacterial infection and the surrounding is too cold and it would cause them too much energy to develop the fever, they might go into a second reaction, which we also have, and that is a hypothermia reaction, where they actually go into cold. And this we sometimes see in patients with very severe sepsis on the intensive ward as well, where we have to ask ourselves, should we be giving them more warmth for them to be able to for the cost of developing the fever to be worthwhile. And there are rare heart rhythm conditions, one, for example, Brugada syndrome, where fever can cause heart rhythm problems, which can be dangerous. But these are rare conditions, and in a normal situation, fever is not dangerous. And I often use the example of also the animal world to help the patients understand that the body can deal with higher temperatures, that higher temperatures of 40 degrees do not lead to proteins being damaged. And first, the dove. Normal doves live at 39.5 degrees temperature. That's their normal temperature. And when they have a fever, their temperatures goes up until 42.2 degrees sometimes. The camel actually actively keeps its body temperature sometimes at up to 40 degrees Celsius to avoid losing water, because it would need to evaporate water to cool, but it needs its water to cross the desert. So it has a special fur that actually keeps it cold, that keeps it isolated from the surrounding, and it also keeps its body temperature higher to have less difference to the surroundings and to need to evaporate less water. And that's why the camel's body temperature can vary between 34 degrees and up to 40 degrees. And another example, a very exciting example, is actually the desert ant. There are some desert ants that can have a core that can be active at a core body temperature of 50 degrees, and that can survive brief core body temperatures of up to 55 degrees. Now, these are very special ants with long legs to keep them a little bit higher away from the hot desert ground. And with their long legs, they wander across the hot desert looking for other animals which did not survive the heat, and quickly grab some prey and go back into their hole to cool down again. And scientists have wondered, how is that possible? Because those are temperatures at which one would normally not survive. And they found out that these ants produce so-called heat shock proteins. These heat shock proteins come around the other proteins and protect them from the warmth and keep them from denaturating. And we recently have shown that humans also produce heat shock proteins during fever. And these heat shock proteins protect the brain and sensitive tissues against the high temperatures. So we have a multitude of processes in the body that help the body deal with the higher temperatures of fever. on the one hand, and prevent the temperature from becoming too high on the other hand. And unless these centers are disturbed, like through a brain injury or through hyperthermia, for example, if you've let your child too long in a hot car and it gets really overheated, those are cases where these centers are disturbed, and then you need to cool the child. But if you have a normal, natural febrile reaction to an infection, then you do not need to worry about the height of the temperature.